Good morning all. It's Postbag. Let's start with this one. This one has a piece of wire running around there which feels a bit USB pluggy, but the one on the other end I can't quite make it out. Let's cut into it like that. Oh yes! Yes, this is a USB charging cable with a little volt and amp meter built in. That's excellent. I've got to plug that in right now. So I think the logical thing to do with this is to charge one power bank from another power bank, and actually then what I can do is I can switch it the other way around, charge the big power bank from the little one. So let's see whether that powers up. Yes, it does. 5.16 volts, 0 amps, because we're not drawing any current. So let's plug that into the charge port of this and see the current that's drawn. Not a lot, 5.11 volts. Oh, no amps. Why's that? Is this fully charged? No, that's charging. Well, that's not a good start, is it? Let's try that again, because something fell off. Oh, it's the cover of my power bank. Let's just plug that in again, because I'm sure that was charging. But now it's saying no amps. What's going on? I'm sure that means it's charging when it's red. Yeah, I think that goes out when it's no longer charging. That's on. What's going on? Let's plug it in the other way around. So using the small power bank as the source, let's switch that on. 5.2 volts. Plug it into this. It's that way around. Ah, yeah, that's drawing some current. I wonder why this one wasn't. Maybe the battery's full. 0.6 amps. 0.61 amps. Well, that seems to work. That's rather good. I like that. I might take that apart at some point. What's this on the side? I've just seen a switch that has fast charge or USB data, and you can switch it between those two things. So does that fiddle around with the D plus and D minus lines? Interesting. I think this is going to have to come apart in order to see what that switch does. So here's the item on eBay. It's a smart voltage current LED display micro USB sync data fast charging cable. 1.2 meters. It's not 1.2 meters. It's a fraction of that size. It's $2.99. Free shipping from CZB. CZB really I should say. 672-1960. Okay, now we come to the other item in this package. What's this? Oh, it's another one. Why would I buy two? Oh, I think I bought a long one and a short one. So this has a smart display also. Oh, 4 foot. There we are. Yeah, so this is a long one in a rather nice retail box. So let's open that up and get this thing out. Oh yeah, so this is the 1.2 meter one, 4 foot. Well, let's try that, see if it's the same. Yeah, well, they look pretty much identical, apart from the voltage reading, which is, well, quite substantially different. Oh no, wait a minute, of course I'm on 2 different ports of the power bank, so I ought to swap these over. 506 on the long one, 516 on the short one. Let's switch them over. Okay, now we got 507 on the long one, 516 on the short one. Oh, I can't remember which was which. So short has the higher voltage. I'm pretty sure the short one had the higher voltage before, which means that the voltage reading on these things isn't very accurate. So short has the higher voltage. Let's switch them over again. Yeah, so the short one once again has the higher voltage. Yeah, so there's definitely a discrepancy between these two units. Doesn't matter which way I connect these ports. The short one is reading the higher voltage. Now, it's not because it has a shorter wire. There's no load, so there's no current. So there can't be any current or voltage drop across the cable. No, it's just that these things aren't very accurate. So here's a short one, I think it is. You see, the truth of the matter is I bought these so long ago that they've actually dropped off my purchase list. Well, they're in the purchase list, but there's no link to them anymore. So I'm just having to find randomly similar ones. This is a micro USB voltage current smart LED display fast sync cable. All that stuff. This one's $3.25. Free shipping, and this is from Princess Dress 08. Is this a short one? It doesn't actually give the length. What about in the description below? Ah, yes. Cable length is 1.65 centimeter. 1.65 centimeters? Just over half an inch? I don't think so. But they're quite neat, aren't they? I mean, despite the fact that they're not very accurate, this one is reading a good 1/10 of a volt higher than the other one. It does give you... Why does that keep going to 0 current? This must be fully charged. That's weird. It does give you an indication of voltage and an indication of current, and that's quite useful. Well, now here's one that just says Julian Islet, United Kingdom. I wonder what that thing says in the middle. Let's do my Chinese to English translation. It says the Netherlands Postal Flat Mail Global. What's that stuff at the bottom? Oh, gibberish. Child. River, river. Book, book, book. State. What's all that mean? Okay, let's take a look in here. What do we have? Don't know, let's open it. Well, it appears to be a watch. Why did I buy a watch? Oh, that's quite a nice colour. I think this might have been one of these 50p things, and I bought it because it was just uber cheap. Let's get in a bit closer. That's interesting. It's got a sort of Swiss flag thing there, and it says Gemius Army. Is that supposed to be a bit like genuine army? Also, those side dials are just blanks. They don't actually do anything. Now, interestingly, there's a plastic thingy bob in there. Is that going to come out? And then presumably I can press that in and the thing will start running. Oh yeah. So it's got a battery in it. I can't really remember what possessed me to buy this, but it's quite nice. It's all made of metal. I think I'm going to have to... Oh look, there's my camera. I think I'm going to have to take the back off this and see what's inside. Well, I can't see any place on the back that actually has a slot where you can put a screwdriver. So maybe I'm just going to have to jam it in anywhere. No, that's just going to damage my screwdriver. How about a knife? So if I can get the blade in between the back and... Oh, that's just scratching the paint. No, that's not going very well. It does work though. Can you set the time? Yep. It is only time. None of the other dials do anything. What's the time? About 10:30, something like that. Well, perhaps you don't take the back off. Perhaps take the front off. Oh no, that's just splintering the glass rather badly. No, I definitely need to get the back off. I'm just not quite sure how. What if you rotate it? No, that's not working. This thing's got a really loud tick. Let me put it by the microphone. But I still want to get inside and have a look at what is in there. Right, I've got the back off by sliding the knife in. Finally managed to do it. Oh, it's a tiny little watch inside a big case. Let's take that out. How does that come out? It really doesn't, unless that unscrews. I don't think it unscrews. That's all wobbling around now. How do you get this thing out? one doesn't know. Right, I've managed to get that sort of adjustment dial thing off by just gripping this, what looks like a threaded rod, and that looks like it was screwed onto it, so that comes out, and there's the watch. Beautiful. Gemmius Army. So let's take a closer look at the electronics, if indeed we can see any electronics. So I'm going to have to get this plate off somehow. Not sure quite how to do that. Oh, all the hands have fallen off. That's interesting. How's that plate held on? With a couple of little stud pin things. Oh, I seem to have bent one of them. That's a shame. So let's get in a little bit closer. This is really testing the close-up ability of my lens. There's the crystal, and you can see a couple of solder points where that's wired on. There's the chip, and there's the battery. So let's see if I can remove some of this. Good, battery has come out. Now we can start to see some of the mechanics. There's the little coil of wire, which is effectively a stepper motor, I suppose. Just wonder whether I can get into this gearbox and see how that works. Yeah, there we are. I'm in, and there are all the tiny little gears. Oh, they're my new. Oh, one's popped out. They're plastic. Other one's popped out. Oh, another one's out. Yeah, that one's out. So how does this stepper motor thing work? I don't know. Interesting. Well, I'm trying to get the stepper motor to turn by connecting the battery to various points on this circuit board. But I'm not getting on very well, as you can see. Well, I really wanted to get that stepper motor to turn. Where is it? This thing here, that main cog there, sort of driven by pulses on this this solenoid, this little thing with wire wrapped around it. But I can't work out where to connect the battery. I've tried various test points. I've probably blown it up. So I think this watch has had it, but yeah, intriguing how tiny all this stuff is, isn't it? Yes, so bye-bye green watch and all the various bits. Bye-bye. Let's see where that came from. Well, from my purchase history, I can see that I paid just 99 US cents for that watch, which is absolutely remarkable. I can't find anything identical, but here's one that's kind of similar. This one's got 3 dials. Again, a load of fake secondary dials here. 99 cents, free shipping, and this one is best for no one. Okay, I like the look of this one. It's rectangular and reasonably heavy. Let's see what this is. Oh god, what's this? I have no idea why I bought this. Amazing Revolution magically hangs in mid-air. It's just a magnet, isn't it? I mean, there's nothing really very clever about it at all. It's just, I mean, you can see it's magnetic because it kind of, and then this thing sits against, and if you get that positioning right, it magically hangs in mid-air. What's clever about that? Okay, well, let's put this plastic end piece in. So this is all it is. It's got a plastic sort of end piece there. I suppose that's supposed to look invisible. And then, I mean, if you put it there, it just sticks to the magnet. Whereas if it sits up against that end piece, yes, it floats in midair and you can spin it round. But I mean, that's not really very interesting, is it? Well, I suppose it's interesting for a couple of minutes. Oh. Next. Actually, there are some screws on the back. I wonder what it's got in here in the way of magnets. I wonder if they're quite big. Well, they're not that big. They're sort of these triangular magnets. They're not neodymium or anything fancy like that. So if I hold that in approximately the right position, yes, that will float above the magnets. like so. No, it's rubbish. Well, I suppose I have to show where this came from. I can't find the one I bought, but this is very similar for a very similar price. Why did I pay that much? This is new anti-gravity revolution magnetic levitation device science educate toy. You can choose different colours. As I say, $4.79, free shipping. And this one came from More Things. Actually, I quite fancy one of these wireless Bluetooth magnetic floating levitating speakers. But they're not cheap, are they? Yeah, I've been buying some really weird stuff lately. I think I got a bit over hung up on this sort of cheap stuff thing. Anyway, this one says electronic components, so let's hope that this is a bit more electronical. What do we have here? That's interesting. What's that? Well, it's a load of USB lights. It looks like 10 of these USB LEDs. So back to the power bank. Let's plug these in. Oh yeah, they're nice. They just they've been scored, so they just snap off. Yeah, I mean they don't do anything really clever. They're not like touch or anything like that. They're just 3 LEDs and a resistor. Let's take a look at the value. So from the track arrangement, it looks like there are 3 LEDs in series, and there's a 390 ohm resistor, and that's it. And this item is 10 pieces card lamp bulb LED keychain, mini LED nightlight portable USB power white, $2.37, free shipping. And these came from, and this is actually the one I did buy, these came from Zumesh Zero. And I think the idea of these USB lamps was that they would go with this, if this is indeed what I think it is. And it is. It's a 7-port, is it? USB 2 hub with switches. Let's put some lights in it. Yeah, so individually switched USB ports on this hub. Let's put the lights in it. Yeah, that looks pretty good. I'll just put a few in for the moment. Let's plug that into the power bank. Switch that on. That's on. Oh yeah, you've got these nice blue lights. And yeah, these light up when you plug them in. Now, I can't quite remember what the idea behind this was. Possibly a novel light fitting, a novel light fixture. It's actually quite nice, isn't it? But I think the idea was something to do with supercapacitors. I think I was going to put a supercapacitor on here and use this as a sort of variable load or something, but I don't really remember what the thinking was. It is a while since I ordered this. Well, this is interesting. On the package that it came in, it says 1 upstream and 4 downstream USB port included. Well, it's not, it's 7 downstream. Data rates here, but it also says bus power limit current protection 500 milliamps. Do we believe that this thing actually has current protection of 500 milliamps? I suppose we could have a look inside. It doesn't seem to be screwed, the base. It looks like it might just be pressed on there. There is actually a socket there for an AC power pack, but there's no mention of it in the blurb. So let's try getting this base off. It looks like it's just pressed on. Yeah, it looks like it's just pressed onto little studs. So that should just pull off, and then we can have a look to see if it's got this current protection, which I assume would just be a polyfuse, a 1/2 amp. Wow. Oh yeah, of course this is all the USB hub stuff, which I'm not using. I'm just using it as a power distribution unit. Oh, that's fallen out. That's quite fun. So now we can just see the PCB. Well, I can't see what I'm doing very well, so let's turn these off one by one. I can't see any fuse on here. There's some really weird pads, tracks that have been sort of added on, almost as though they've turned a single-sided board into a double-sided. You've got the tracks on the board, but there are sort of additional tracks. Let's get in a bit closer. Yeah, it looks like they've sort of added these tracks on by sort of putting some sort of extra layer of green stuff, and then, I don't know, an extra layer of possibly copper, and then it's coated in black. That's really weird. I wondered where these wires were going. They're actually not going anywhere. They're the ends of the LED leads, and they've just been bent over rather than being cut off. They've been bent over. That's really strange. So the incoming power is the red and black, presumably, the outer two wires on these four. In fact, we can probably see that. What does it say? Ground. I can't see that. Ground. Oh, there's 5 wires, 2 grounds. Oh no, one's not used. Yeah, it is red and black. 5 volts, DM, DP, D minus, D positive, ground and ground. But there's no polyfuse. There's a capacitor there, another capacitor there, but no polyfuse as it goes into one of the hub chips. And there are no polyfuses on these USB output sockets, these things here, which I've plugged my lights into. So I don't think this thing has any form of protection at all. There's a 0 ohm fuse, a 0 ohm resistor there. That's not a fuse. So no 500 milliamp protection. I reckon I could draw a lot more than 500 milliamps from this. But USB hub nonetheless. I think as a the power bank's turned off. I think as a lighting appliance, this is rather nice, actually. I'm quite glad I bought that. Can't remember why I did, but yeah, that's rather nice. And finally, this one says, I don't even need to cut this, says on the front of it, farad capacitor. So I think I know what it is. I think it's the bank of series connected supercapacitors, which makes up kind of a 12 volt pack. Let's open this up. This bag is absolutely filthy. It looks like it has a Banggood part number on it, but I'm not sure. It looks like it's been hanging around a while. So yes, this is a bank of 6 ultra capacitors or supercapacitors, 2.7 volt. How many farads are they? 120, is it? 120 farads? Can't see. Let's have a closer look. So yes, I'm pretty sure these are 120 farads each. They're not the biggest supercapacitors. 2.7 volts. 2754, 3 times 54 is 150, 162. So 16.2 volts is the maximum you could take this to. Usefully, I suppose you could use it as a 12 volt pack. Of course, with capacitors, there's no actual voltage limit other than the limit that would cause damage, and they don't sort of rise up and then go flat. They have a constant voltage rise if you put a constant charge current into them. Now there's some interesting components on the back. Let's close in on that. So here are the connection points. This is one connection, and then the capacitors go round here, round and then back again. So these are the 2 outer connections of the 6 series connected capacitors, and each capacitor has a couple of 100 ohm resistors, so in parallel it would look like, so that's 50 ohms. A switching device, now that looks like it's a MOSFET. The gate is there connected to this other device. The source is sitting down on this connection pad, and drain is the tab. So what that's doing when switching on is it's pulling these 2 resistors from one side of the capacitor through the MOSFET to the other side of the capacitor. So it's simply draining, would it be charge out of the capacitor, letting a current flow, and therefore bringing the voltage down. So the question is, what is this device that switches on the MOSFET? Well, it must be some sort of voltage measuring device, so that when the voltage across the capacitor gets to a point where it's dangerously high, this device turns the MOSFET on and puts this resistor across the capacitor, and therefore causes it to discharge. The question is, what are these devices? Well, we've got a 113 and then a funny symbol. I'm not sure quite what that is. But that's almost certainly a MOSFET. It just is laid out like a MOSFET would be laid out. Now source would be to the, if that's N channel, source would be to the negative. So that pin would have to be the negative of the capacitor. I'll check that in a moment. But this one, C73X, I think that one might be worth looking up. Yeah, so I was saying that source would have to be to the negative of the capacitor, and you can see immediately that that is the negative side of the capacitor. So this is almost certainly an N-channel MOSFET requiring a positive voltage on the gate to turn it on, assuming it's enhancement mode, which most of them are. So yes, I'm going to look at that C73X. Well, it's not in this SMD data book, which I've just found online, which goes from C7 to C75, so it's not in there. Where did I find this data book? It does look like quite a good data book, and I found it at this URL if you're interested. Well, I can't find any references to this actual device, this C73X, but there are a lot of circuits for supercapacitor protection that look a bit like this. There's a device here. Now, that's not actually a MOSFET. That looks like a Darlington. I mean, maybe that's a Darlington. It should be a MOSFET, really. Although possibly there's a problem with gate voltage. But here you can see there's just some sort of op-amp here, a Zener, a 2.4 volt Zener, which sets the upper limit probably. Well, it's a comparator really, isn't it? And then that switches on this device, which shorts out. Now this circuit doesn't have these resistors, but it shorts out the supercapacitor here. In fact, there are two here in parallel. So it's going to be something similar to this. This circuit doesn't have all these resistors and the Zener. I mean, maybe that little chip is a special purpose supercapacitor voltage measuring device which turns on the MOSFET, which puts these resistors across the supercapacitors. Something along those lines. So what might be quite fun to do is to charge this series pack and attempt to charge it beyond the maximum 16.2 volts so that the individual cell protection or capacitor protection circuits kick in. And then on this one here, which is on the most negative end, that is negative, yeah, look at the gate of this MOSFET, or if that's the base, if it's a transistor, just monitor that with a DVM and wait to see that line go high, which means that this has been turned on and therefore these resistors have been put across the supercapacitor. So I think I might have a play with that in a future video. This looks like quite a fun device. Not massively expensive, I don't think. Okay, yeah, it's a little bit more than I thought it was. I couldn't remember quite how much it was, but this is a farad capacitor, 2.7 volt, 120 farad, 6 pieces, supercapacitor with protection board module, $17.28. There is also a 69-cent shipping charge, and the one I bought came from Bywee City. Further down, the specifications are rated voltage 16, rated capacity in farads 120. Well, of course it isn't 120, because if you put capacitors in series, you have to reduce the capacitance, so it would be a sixth of that, which will make it what? What's a sixth of? Yeah, 20 farads only. Not that that matters, because you've got the additional energy storage. And they call it, well, up to 1 million times charge-discharge. I suppose capacitors can be charged pretty much indefinitely, as long as you don't damage them. A farad capacitance. Now, it's just occurred to me that quite a good charge source, current source for charging this device, would actually be a solar panel, because the 36-cell solar panels for charging 12-volt batteries actually have an open circuit voltage of sort of getting on for 18, 20, possibly even more than 20 volts. Constant current, of course, with constant illumination. So that would be quite a good charge source, and it should take this thing over its 16.2 maximum voltage, and so all of these protection circuits should kick in, and you should have presumably 50 ohms, 50 ohms, 50 ohms, sort of 300 ohms across that voltage once all these kick in. So if you look at the current, you could probably work out whether these protection circuits were switched on or off. Interesting. So I'd probably go for something like one of these panels, these 5-watt panels. Not today though, because despite the fact that it's August the 2nd, it's actually pissing down with rain. Yeah, I'm not entirely sure what's happened to our summer this year, but it just really isn't happening. The clouds are completely covering the sky. So yeah, I think this supercapacitor module actually could be quite a lot of fun to play with. But anyway, here are today's Postbag items. Cheerio.